We are going to the last presentation today because what it would be Tech Day without talking about AI. So we have Furkan here who will talk about using AI in DNS abuse mitigation.
Hello, everyone. My name is Furkan Çolhak, and I will be presenting AI techniques in DNS abuse mitigation. I'm a student at Kadir Has University and researcher at Cybersecurity and Critical Infrastructure Protection Research Center. I want to emphasize that we are not introducing any products, any softwares. We are introducing our research papers. One of them is SecureReg, and one of them comparing deep neural networks and machine learning for detecting malicious domain name registrations. And here is the agenda. We will start with introduction. Then we will quick look up the current landscape of domain abuse mitigation, requirements, research objective. Then we will explain our methodology. Then we have results and conclusion. The domain name systems is converting human readable domain names into physical addresses. I don't want to express that, by the way, we all know. But I can express it in cybersecurity perspective. I can describe it like for energy utilities, for instance, if electricity interrupts or gone, what we are going to do? It is going to be very catastrophic environment, right? This is why we are calling energy utilities in cybersecurity landscape as critical infrastructure. And DNS is critical infrastructure for whole internet. Of course, its significance also makes it prime target for cyber criminals. And we have some attacks like cache poisoning, DDoS attacks, hijacking, and tunneling. And these attacks are getting dangerous every day because it is all AI supported attacks. How we can mitigate it? We can mitigate it with AI too. I need to emphasize about domain abuse because previous targets is always using the system vulnerabilities, machine vulnerabilities, but domain abuse using the human vulnerabilities. This is why making any prevention techniques getting harder every day. I want to describe domain abuse. It is registration, domain registration for malicious activities. It can be phishing, it can be scam, it can be virus, any kind of things. Also, I can have a system that domain abuse activity reporting system tracking various this type of and labeling campaigns like that. It is very crucial. And AI in domain abuse, why we're inspired with AI? Because these human vulnerabilities can be detected with AI. We all know from ChatGPT, right? We're all using ChatGPT. And when you're prompting something, sometimes when you are writing text math, it's all understand your also behavior. So it's very talented tool. We can use it for mitigation domain abuse. Also, there are some existing solutions for each registry. They have prepared some systems, for instance, .uu proposed Premodoma system. It is using machine learning and it is focusing on detecting malicious large-scale campaigns. And it have a limitation about it's not detecting one single malicious activity. .ba.ch also prepared some static rules-based method, but it's hard to sustain it because trends are always changing. .uk also prepared the system, but it is very limited public information available. Due to that, we cannot view their techniques. .nl also provide reg check, and we are inspired by reg check, we need to say that. They are using logistic regression for assigning risk scoring for each newly registered domain. And they have some performance limitations about it. When we overview these systems, we notice that we can set some requirements for these existing solutions or new solution. The one element is accuracy. So we have to minimize the risks. And second is simplicity. Domain name registration are using millions of time in a year, so that we have limited computational power. We need to choose simple technique to mitigate it. Also, the third one is sustainability. It is also important because I have mentioned before, the trends are always changing. Zone files behavior can be changing in a month. The objective of this study, we want to use natural language processing and especially pre-trained models. Pre-trained models, what it means? It means language models like ChatGPT. It's also know some knowledge before, but you are trained according to your specific case. It is very complex models. It is working with deep neural networks. And because of that, we want to also compare with simpler machine learning models. Here is the registration system overview. You can see new registration comes to registration database, and we have registration connector, and registry operator also updates the zone file. Our approach is located on between new registration and registration database. What is it includes? It includes data processing. Then we have model part. We will compare deep neural networks and machine learning. And also, we are labeling each of the registration as benign and suspicious and sent to registration database. Here's the data set. Due to limited publicly available data set, DNS data set, for instance, the previous systems doesn't share data, so we cannot compare each method. We have created our own data with MTLP data set. It contains URLs, and we take the URLs and extract domain names inside. We have removed protocols, subdomains, top-level domains, file paths, etc., and we're using pure domain name. We drop the duplicates. Then we have some features. As textual feature, it's already domain name, and we have numeric features, like we are deriving some features, total length, special character count, etc. Why I'm saying it? Because we have different methodology. We are using textual and numerical features both. Textual features, just single textual cannot be understood by machine. So you need to express in machine language. You need to binarize it, you need to getting numerical, and we are providing it vectorizers and tokenizers. Pre-trained models are using their own tokenizer. And for machine learning models, we have applied TF-ID vectorizer. And we are combining numerical and textual features, and we are getting output benign and suspicious. We have some model results here. As you can see, we have some metrics like accuracy, precision, recall, and F1 score. What is this metrics? Accuracy is total accuracy. Precision, I can briefly explain that it is the accuracy of highly distributed class, and recall, it means false positive rate. So if you want to detect more malicious activities, you can focus on recall. If you want to detect more benign, it is precision. But we want to use advanced score because it's harmony of them. Also, training time is going to be used for sustainability. Model size will be used in simplicity. We have several models like K9, Bert, Roberta, Albert, MobileBird. It is very popular. It is language models like ChatGPT. You can easily import and use it. Also, we have traditional machine learning methods like random forest, support vector machine, KNN, XGBoost, and logistic regression. For better understanding our topic, we have a table 3. As I mentioned before, we have some requirements like accuracy, simplicity, and sustainability. In accuracy part, we have some observation like K9 have some 86 around F1 score, and the best score from machine learning is just 83%. So it is about, there is a difference about 3%, right? It is very huge, by the way. Because when we briefly looking up, 3% is very low rate, but when you're thinking about millions of registrations, it is very huge. For simplicity, again, deep neural networks has minimum 140 megabytes. When you are looking at the machine learning models, there's a huge difference. It is also very important because we will use lots of computational power, so that we have to determine the lightest models. For instance, logistic regression is not even 1 megabytes. For sustainability, K9 trained in 591 seconds. But when you're looking at the machine learning part, it is not just 1 second. So it means logistic regression trains not 73, by the way. We missed 1 0. There is a huge difference like that. And of course, we have some conclusions. Our presentation builds on our previous research for AI techniques to detecting domain abuse. We have reviewed existing solutions and identified their requirements. And we have applied some natural language processing methods and pre-trained models comparing with machine learning models. We have some key trade-offs between accuracy, simplicity, and sustainability. When we are looking at the accuracy level, DNS, deep neural network is better, right? But it needs lots of resources, lots of training times, lots of larger models. So when you're thinking about real-time detection, machine learning is very light, very sustainable. So it's up to executives, by the way. As a researcher, I can be quiet, but I cannot have a decision. Our future work will be, we want to work with real data. We want to working with DNS registries to implement as a real system. So here's our references. Thank you for your listening. If you have some questions, I can answer it.
Questions, please. Or I will ask. You mentioned the limitations of these current approaches from DonNLB and URIT. Did you talk to them maybe about this? Like, do they think that maybe they could
No, we don't have contact about it.
No.
No.
I believe that they are all here, so
we can meet, by the way.
feel free to get in touch, and I think that you can help them improve their.
Maybe they can be aggressive for limitations.
Maybe my second question is like, do you already, you mentioned at the beginning, it's just a research, not a product, but I would guess that you may have some like a software that is like doing this stuff, so that could like be open sourced and so anybody else can play with that.
We are sharing our codes. We are sharing our data. They can apply whatever they want. They can just click our research papers and reach our resources.
Okay, good, great. So unless if there is no other question, thanks again. So this was the last presentation of today, and now I will hand over to my colleague Andre, who will do a wrap up.
Hi, sorry, really quick. It looks like there's a hand up
Hello, yes.
in Zoom.
Can you hear me?
Yeah.
Can you hear me?
Can you please speak a little bit louder?
Yes. Hello, this is Thijs van den Hout from SIDN. Thanks for your presentation and the research. It's good to see that this topic is getting more attention, and we were glad we were able to inspire you with RegCheck. Some of the figures you show indeed look very much like our system. We presented RegCheck last year at the Tech Day in Hamburg. I have one remark and a question after reading your paper. So building an AI system is difficult, but deploying it in production is even harder. And it's very important that the data set that you test your work on is representative of the real life deployment scenario. And in your data set, you have about 50-50 malicious and benign domain names, while in practice, this is very much more imbalanced, with just a few % malicious registrations. So if you don't take that imbalance into account, the model can produce some very unexpected results in practice. So I don't really agree with your statement about the performance limitations, since we do evaluate it on this very imbalanced data set. So it's not really a fair comparison, but we're happy to test this with you